I know, word problems, they can be so scary. Let's not be scared. The population P of a predator mammal depends on the number of a smaller animal that is its primary food source. So P depends on X, and that's given to us by that relationship right there. Okay, whatever X is, X represents the number or the population of that smaller animal. But the smaller animal population, S, is dependent upon the amount of a certain amount A of a certain plant. Okay, so the population of the predator mammal depends on the number of the smaller animal, which depends on the amount of that certain plant that's available. And the amount of the plant is called A. So S depends on A, P depends on X, and X is the number. X and S are really the same thing. Okay, meaning that X represents the population of the small animal. Okay, so if X represents the population of the small animal and S also represents the population of the small animal, then we just have to replace X with S of A, and now the population of the P, so P represents the population of the predator mammal, and so capital P, population of the predator mammal, depends on, now is going to depend on how much of that certain plant that is its primary food source is available. So P dependent upon S, which is dependent upon A, is equal to, it says the input for P goes right there. You have to square it, okay, and then you add 8. Well, again, that S of A is at 2A plus 2. So that goes right there, 2A plus 2. So 2A plus 2, and if you want to leave it like that, it's totally fine with me. Okay, but that's it. That's the population of the mammal, which is really indirectly dependent upon how much of that certain plant is available for the smaller animal. Because the more that plant's available, the more smaller animals there'll be, and the more food that predator mammal gets to eat. Okay? So there you go. If you want to pause the video and give this one a try on your own, feel free. Okay, I actually haven't previewed this one, so we're doing this one together on our own. Or together on our own. That doesn't make any sense at all. An oil well off the Gulf Coast is leaking, with the leak spreading oil over the surface of the Gulf as a circle. Okay, so we did this in the beginning. At any time T in minutes after the... We already did this one. That's lame. Sorry. I didn't realize that this was part of that. So let's see if you can figure this out on your own without rewinding the video or going back to the first video. So we've got the radius of this oil slick is dependent upon time. Okay, well, we know that the area, again, is dependent upon just the radius. And so if the area is dependent upon the radius, and the radius is dependent upon time, then we can just write the area in terms of time. So the area in terms of the radius is now pi times 3t squared. So area now dependent upon just time, because the radius is dependent upon time, and so we just eliminate the r and just write it as 9 pi t squared. So if we want to know the area of that oil slick, then we would just figure out, well, what time do we want the area of the oil slick, because the oil slick area is increasing, so you can't just say the area of the oil slick because it keeps moving. So something that's changing with respect to time is you can't just say what's the area. The question is what's the area, well, when? Alright, so when t equals whatever, that's when we can find the area. Okay? Sorry about that one. That was an oversight on my part. Nevertheless, number 11. See if you can do this one on your own. Okay, you haven't seen this one yet. Surface area of the balloon is given by, so you should be paused. You should have already paused the video now. We've got surface area of a balloon is dependent upon the radius. Okay, see if you've got a balloon, blowing it up, So the radius of the balloon, as it increases, so does the surface area of the balloon. Okay? If the radius, though, is increasing with time t, so you're blowing up the balloon. And when you first start, radius is 0. Keep going. T equals 1, t equals 2. The radius keeps increasing. So according to the formula, the radius, let's see, radius is increasing and the balloon moves. According to the formula, radius is dependent upon time. Find the surface area as a function of time. Well, alright, so we know that the surface area is dependent upon r, 4 pi r squared. We know that r is dependent upon t. Okay, and so we're just going to replace r with what r of t is equal to. So that's 3/4 t cubed. And it doesn't really make any sense. Don't forget to square that. It doesn't really make any sense that t would be a negative number here, so that would be the domain restriction, would be that t has to be greater than or equal to 0. And let's see if we can simplify this a little bit. It would be nice for the teacher to not have to try to figure out what you mean here. If you can simplify it, then all the answers will be the same. So we have 3 squared over 4 squared multiplied by t to the 3 times 2, or t to the 6th, canceling the 4 there. 4 goes into 16 2 times. Then we get 9 pi over 2 t to the 6th power. And do we have any feet? Radius of the balloon, feet? No, we're not given any units of measure here, so we can leave it alone. So the surface area now really is only dependent upon, indirectly, it was indirectly, now it's directly dependent upon t. Okay, that's 7 minutes. I think we can finish up this last part in this. You know what? I'm going to search for a couple notes here. So we're going to do this last part here, the right column of the second page, in the next video.